Hello, future toppers. Let's make maths simple, intuitive, and fun together. So, we are back with wholesome new chapter named Differential Equation. This is very important for mains and advance. You can expect one question from this chapter, and that question is solvable. Like you have four parts in this whole chapter which we have to discuss. The first part is variable separable method, second part is linear differential equation, then we have exact differential equation, and then we have homogeneous differential equation. These four things we will study in this chapter now. So, and this chapter is very important in real life as well, because this thing is used in medical industry, engineering field. There are so many fields it is being used. Like, do you remember that during COVID, like on so many news channel we used to talk about this thing, that by the end of 2050 the whole world will be vaccinated if we will cover up vaccination in this speed. Okay, so these kind of things they used to say only by using differential equation. Okay, rate of rate of applying vaccines to the people with respect to time. So these things we will study. So now let's jump on to the chapter. So first we will try to understand what is differential equation. Okay, so this is the definition of differential equation: an equation which includes independent variable x. Look at this. Do you remember that we used to write down function f of x is equal to something in x? Okay, that something in x is independent of everything. We used to give that some input, so it is independent. And dependent variable y, so this is dependent variable y is depending upon x. The input which you will give to x, it will process, then it will produce some output, and that is y. So y depends upon x, so that's why it is called as dependent variable. And derivative of dependent variable with respect to independent variable means dy by dx, d2y by dx square, d3y by dx cube, and so on. So this, okay, so dependent variable x, then y, then dy by dx, d2y by dx square, d3y by dx cube, and so on. So these combinations has to be available in the differential equation, then only you can say that it is differential equation. Okay, now the two important thing comes under this differential equation. The first one is order. So what is the order? Like if I'll give you some differential equation, I'll be asking you what is the order of this differential equation, and then I'll be asking you what is the degree of this differential equation, and then you have to respond accordingly. So first try to understand what is the order. Order is the largest differential appearing in the differential equation. So I'll be giving you differential equation, and the largest differential appearing, differential means what? The dy by dx, the d2y by dx square, the d3y by dx cube. So these are the differentials, and the largest of them will decide the order. Like suppose max to max, like do you remember we used to talk about what is the degree of the polynomial? The highest power of x you used to mention, sir, the highest power of x is defining the degree, है ना? So here also it is the highest differential is defining order, means how many times you have differentiated the given function. Okay, so if maximum is 3, this means you have differentiate this polynomial 3 times, so highest differential is 3. Okay, so that will define the order. Now we have second component, degree. The degree of the highest power of highest differential. So first you will find out who is the highest differential, and then among those highest differential, the highest power will decide the degree. Suppose in a polynomial you have third order differential, okay, and like there are three things in which third order differential is involved, okay. So among those three things, the highest power of these d3y by dx cube will decide the degree of the polynomial after converting it into polynomial form. So first you have to convert it into polynomial form, then you have to respond. And polynomial in differentials means dy by dx, d2y by, like polynomial, like if I'll tell you what is polynomial, you will focus on x, okay. So sir, a naught x power naught, a1 x power 1, a2 x power 2, and plus minus this combination. So you will be imagining this polynomial in the form of dy by dx power 1, d2y by dx square power 2, and so on so forth. Means this this equation should have, like in place of x you will be using differentials, nothing else, okay. So let's jump on to the some examples for better understanding of order and degree. Find order and degree of the following differential equations. So look at this. So we have this differential equation, correct or wrong? It is correct. Now first we have to find out the order. Order means what? The highest differential. The highest differential, if you'll observe, sir, this is d2y by dx square and this is dy by dx. So dy by dx, this means the highest differential is what? d2. So order is 2. Now degree. So for degree you have to convert it into polynomial form. Polynomial form means the dy by dx will carry whole number as the power. So first we will convert it into polynomial because this is 1 by 4. It is not in the form of polynomial. So first what we will do, we will take power 4 on both sides. So if you will take power 4 on both sides, you will have d2y by dx square power 4 equals y plus dy by dx power 6. So this is the highest differential, okay. This is 2 times, this is only 1 time. So among both of them, who is the highest? This. And the highest power of this highest differential is 4. This means degree is 4. I hope this question is clear. So for degree, first you will convert it into polynomial, then you have to respond. Now look at this degree. So suppose we have to answer degree first and then order. Let's answer order first. So what is the highest differential? This is 1, this is 2 time, this is 1 time. So order is 2. And what is the power of highest differential? It is only 1. So the degree is 1 because it is already in the polynomial form, okay. Now look at this. So first we will answer about order, है ना? And then we will talk about degree. Now look at this. This thing is differentiated twice. So 2 times, 1 time, and 2 time. So look at this. The highest number of differentiation we did is 2. So order is 2. And the highest power of highest differential define the degree, okay. So if you will observe over here, you have this thing inside log. This thing is independent, but this thing is inside log. So you cannot, like if you'll try to convert this into polynomial, na, you will struggle. If you will first, you cannot convert it into polynomial, means The differentials cannot be inside someone's argument. Suppose this is inside log, so suppose you will say that, sir, I will remove log by taking anti-log both sides, so means we will take e on both sides. But look at this, don't you think that the e power will carry these things, means these things will come under the argument of exponential function. Okay, so you cannot convert this question into uh, polynomial form. So for this question, degree is not defined. I hope it is clear, because you cannot convert it into polynomial. That's why it is not, its degree is not defined. Okay, now let's move on to the next question. So first order, then we have degree. Now look at this. So this is differentiated to twice, this is differentiated once. So order is 100% 1. And none of them is inside anyone's argument. Okay, so you have already converted it into polynomial. So what is the degree? What is the power of highest differential? 1. Okay, so sorry, order is 2. Twice you have differentiated, no? So order is 2, degree is 1. I hope things are clear. Now look at this. Again order and then degree. है ना? Now look at this. If you'll observe, this is dy by dx on the denominator. So you cannot have a like differential equation look like this. So you will have what? What you will do? You will multiply both side by dy by dx. So we will be left with what? Dy by dx whole square plus y dy by dx equals to 1. Now things are done. Okay, so what is the order? The highest times what you have differentiated, only once you have differentiated, so order is 1. And what is the, this is, look at this, so both are differentiated once. So what is the degree? Highest power of highest differential. Look at this, both are highest, है ना? But this thing is carrying power 2 and this thing is carrying power 1. So what is the highest power of highest differential? It's 2. Okay, so its degree is 2. I hope things are clear. Now we have this question. Focus on order. Then we have degree. So if you will focus, the highest number of times you have differentiated is this, 3 times. So order is 3. But if you talk about degree, you have to convert it into polynomial. If you'll observe, this is in polynomial, but it is not. The differential is in the argument of exponential function e power x. In place of x, you have mentioned d3y by dx cube. Okay, so this is inside the argument of exponential function. Suppose that you will say, sir, what I will do, I will take log on both sides. I will send these things on that side and then I will take log. But don't you think that this thing will come under the argument of log? Yes, you will get rid of this exponential, but you will get trapped over here. So you cannot like segregate both of them. Okay, so degree for this question is not defined. I hope things are clear. Now we have this, look at this. So first we will talk about order and then we will talk about degree. Now, so if we will talk about order, you know that you have to like find out the highest differential, and it is the only differential, so only once. Okay, now for degree you have to convert it into polynomial form. So if you will remove this ln by taking, like you know that this is inside the argument of log, so you have to take it outside. So what you have to do, you will take e on both side. So look at this, what we will be left with. So we will be left with dy by dx is equal to e power ax, e power ax plus by. Now this thing is converted into polynomial. Why? Look, this has to be, this differentials has to be, like, it cannot go inside anyone's argument. So you have only this as the differential part, not this. This is independent variable and dependent variable, not differentiation of dependent variable with independent variable with respect to independent variable. Okay, so this thing is okay. So what is the degree? Degree will become 1. Okay, means x, y can go inside argument, but dy by dx cannot stay in the argument of any function. I hope things are clear. Now let's jump on to the next part. So we have this situation. Now look at this. Again we have to answer order and degree. Order, degree. Now look at here. If you will observe that for order, it's easy to define order. Directly you will observe the differentials, and the highest number of differential will define the order. So highest number of differentials is 3. So order is 3. Now for degree you have to convert it into polynomial form, means we have to get rid of this power. Means power should be whole number. Now what we'll do, we will take cube on both sides. So you will be left with what? 1 plus 3 dy by dx power 2 is equal to 64 d3y by dx cube ka power 3. Now if you'll observe, if you'll open this bracket, you know that degree depends upon the highest power of highest differential, and highest differential is available over here, not here. Okay, so what is the highest power of this highest differential? It's 3. So order is 3 and degree is also 3. Okay, I hope things are clear. Now let's jump on to the next illustration. Again we have to answer order, degree. Now look at here. If you'll observe, for order you have to observe differentials. So highest differential is 2. So order is 2. But for degree we have to convert it into polynomial form. So we have to get rid of this 1 by 3 as well as this 1 by 5. So what we will do, we will take power 15 on both side, means LCM of both. First, if you will remove this, you will take cube on both side. To remove this, you will take 5 on both side. Correct? So you will take 15 on both side, power 15 on both side. So what we will be left with, dy by dx plus 1, 15 means what? 5. Because 1 by 3 power 15. So power multiply. And then we are left with d2y by dx square plus 1, and then we have 1 by 5 power 15 is 3. Correct? So if you'll open, this is a plus b whole cube. So this thing will carry power maximum, it will carry 3. So order is 2 and the degree is 3. I hope things are clear. Let's move on to the next illustration. Now look at here. If you will observe, again we have to mention order and degree. Order, degree. So look at here, this is dy by dx and this is dx by dy. So here we have problem. Okay, so what we will do, we will take cube on both sides. So we will take cube, it will become 6. So can I write this thing as dy by dx power 6 dy by dx plus 1. Now to write down it in standard form, can I write dy by dx power 7 dy by dx power 6 equals 1. Now for order, what is the highest differential? It's 1 only. One time here, one time there. So maximum is 1. And what is the degree? For degree, we have to convert it into polynomial. We already did it. And we have to consider the highest power of highest differential. Highest differential is this. Highest differential is this. Among them, the highest power is 7. So the degree is 7. I hope things are clear. Let's move on to the next part. So again, you have to answer order, degree. So you know that max to max, look at this. You have differentiated only once. Okay, so order is 1. But for degree, you have to convert it into polynomial. We did it. But look at this. It reaches till infinity. You cannot say that you will stop there. You will stop somewhere at 2000, 2027. It's not like that. So what we will do? For degree, we will say, sir, it is not defined. Okay, because it starts from 0, it reaches to infinity, so we don't know, so it's not defined. Okay, now look at this. Order, degree. Now if you'll observe, you have differentiated this function only once, so order is 100% 1. For degree, you have to convert it into polynomial form. The like differential should not stay in anyone's argument, but if you'll observe, this dy by dx is in the argument of sign. So first you have to remove this, but if you'll remove, you will apply over here. What you will do, you will take sine inverse dy by dx is equal to dy by dx. Look at this. You have removed this problem from this side, but you have created problem over that side. Means earlier this person is in the argument of sine, now this person is inside the argument of sine inverse. Okay, so you know that the differential should not stay in anyone's argument. This means that we cannot segregate them. Therefore, can I say that degree is not defined for this situation? I hope you understood the definition of differential equation, real life application, and you understand the what is degree, what is order. Although this order and degree is not in the part of JEE mains, but you can expect these kind of things. Like you cannot rely, they can ask you in different way. Okay, I hope these videos are helpful for you guys, and it adds some value to your like upgradation. So stay connected, and let's like we will see you guys in next session of MathFlix.